Okay, we're going to talk about making holes and different purposes for holes. So, drilling, threading, tapping, and reaming. This is section 3-6 out of your tech book. Kyle in the background. Okay. Producing, modifying holes with hand tools for acceptable fasteners, pins, or shafts. Drilling, twist drilling, counter boring, counter sinking, spot facing, reaming. These are all hole making operations. In the picture there you have a twist drill right there, workpiece, drill point. Also we have a picture of a center drill and a spot drill. A center drill has a little tip on the front, a little drill, and also has a 60-degree chamfer, and the spot drills are usually 90-degree points, and they're rigid. They're your primary tool to make the prep for the other drills. All right, that's called a counter bore. It's not used as much anymore, but primary function would be making a bore for a socket head screw. You have to drill the hole in the beginning, and it has a pilot that follows the hole and makes a blind hole, a flat bottom hole. So those are counter bores right there with the pilots on there. The one on the top is built onto the counter bore. The one on the bottom is actually replaceable, so you can put different sizes. Pretty much while I'm on counter bores, the speed or the RPM of the counter bore is usually at least half of what the drill cycle would be. This is a pretty typical example of what a counter bore is used for those socket head cap screws to be below flush, or for a spot face that's on a casting and to try and create a flat surface for the bolt to sit on. All right, now we have counter sinks, and there's all different flavors. There's single flute, multi-flute, one that's called a zero flute. And then they have different angles on the tips. Counter sinks also are only used after the hole is put in. All right, there's a really good example of a flathead screw. They cut the block in half. So that is an 82 degree right there. That's metric or American, doesn't really matter. But 82 degree is only used in the flathead screw world. And you can see right there it's a little bit below flush. So where you're doing it, we're testing with a screw, but in the industry they're gonna go to a certain diameter. These are called reamers. One's called a straight flute reamer and a spiral flute. You can use either one, but the front angled corner is the only cutting edge in a reamer. It's my shop teacher told me half the speed, twice the feed. So the same thing is in effect. You need to cut the speed in half from drill to reamer. And reamers are meant for very precise holes of in the 10th range, 0.0001, so you can actually make a hole that you cannot do in a drill, and it gives a superior finish than in a drilled hole. But you got to pre-drill the hole, and it has to be slightly undersized. We have some standards on that, but we like to say 1/64 or 15,000 is a pretty good shop standard. All right, so that's hand reaming. I wouldn't recommend that, but that's actually a NIMS project called a bench block, but we do that in the mill. We use the drill press or the milling machine to help the alignment. The problem with hand reaming is you got to be very steady and straight. So there's a set of vice jaws that actually have brass attachments on there to keep from marring the parts, because the steel grippers on the vice jaw would dent it. All right, these are called expandable reamers, or tapered. One on the right's a tapered reamer for tapered pins, but adjustable reamers not such a great idea. But Actually, the drive on the end of these is square, kind of like the threading taps. So this is this kind of applies to tapping and reaming. You need to have your driving unit or the tool at a 90-degree angle. So I prefer to do it in a machine that helps me with keeping it aligned. Threading and tapping. Okay. On the left is a threading die, usually used to fix threads. To create threads actually requires a lot of horsepower. It'd be very difficult. But we're actually going to make a brass hammer, and we're going to thread the handle using that method on the lathe. And on the right is an internal tap, this is going to be you're doing a lot of that. You're either fixing threads or creating threads. So you have to pre-drill the hole, and we call the hole that you put in there a tap drill. It has to be smaller than the tap. So if you had a 1/4 inch bolt, which is .250, you do not drill it .250. You have to look on the wall chart to find the correct drill, which I believe is the number 7 drill, which is .201 diameter, and that gives you 75% thread. This is an example of thread right there. All threads are 60-degree angles, and the pitch is how far it takes one rotation to travel, and is the crest of, like the crest of a hill, the top of the thread, and the root. So the outside is technically it's called a major diameter, but if it's a 1/4 inch bolt, that's what you're measuring, the outside diameter. And typically bolts are slightly under the nominal size. Nominal meaning the perfect size. So .250 would be nominal, so they typically measure like 245, somewhere around there. The pitch diameter, you can only measure with a pitch micrometer. We don't have that in here, but you can actually, we have another method to do that. And the minor diameter is the small end. So if you're drilling a tapped hole, you're actually creating the minor diameter, and the tap is cutting the threads, which makes the major diameter. On a shaft, it's the other way around. You're turning the outside to be the major diameter, and then you're putting threads on it. All right, so there's a system there of, like, this is the Imperial U.S. system. 3/4-10. It might say U and no U, but NC is a national course, and 3 would be the standard of fit. Like a 2 is a all-day, everyday fit. I've rarely seen those, and 3 I've only seen in the defense industry, so close fit. So you got major diameter in the U.S. system. It's fractions, and in metric it's metric. 6 is 6 millimeter. Threads per inch. And then the form, coarse or fine. So 3/4-10 pretty much tells you all right there. So here's a bolt, 20 threads per inch, so it's 1/2 inch diameter, 20 threads per inch, that makes it a 1/2 inch 20. And then the type of fit, whether it's loosey or very high tolerance. So this is in the middle with the 2, and the A means it's an external thread. All right, so right there you're looking at a picture of internal and external thread. On the upper left picture says 100% of full thread. We typically don't go to 100%. You notice the 75% when you're creating the tap drill hole, that's about what we're creating. But 75% thread is almost as strong as 100%. But if you make the hole too big, now you have very little thread to engage. So you have thread, but it's very weak at that point. And then you have taps. Taps are for creating the hole, threads. So you got to use the proper tap drill size, which is on that Starrett wall chart or many other wall charts. And pictured there are hand taps. Those are hand taps. It looks like a coarse and a fine tap. So you have to use a tap handle that has the square drive on it. Those we use a lot. Those are called, we actually in the shop call them gun taps. They're technically called a spiral pointed tap, but it pushes the chip forward, so they're really only used in through holes when they push the chip forward, but it's one of the strongest taps, so they're hard to break, but not impossible. That's called a spiral fluted tap, and that's for pulling the chips out. Both spiral taps are kind of meant for the CNC or the automated machines, but the spiral flute will act like a drill and it'll pull the chips out. It's actually a very weak tap to use for hand tapping because of that spiral flute. Alright, taps also have different thread forms. So if you notice the beginning of this one, this is called a taper tap. It doesn't become full threads until about the 7th thread. So in order to get full threads, you have to go through to a certain distance, because if you try and make threads, they either want the thread all the way through or to a certain depth. So you got to take that into account and in tap selection. But this tap would actually be probably the best tap to use to start a hole with. That one's called a plug chamfer tap, so it has some taper. You probably could still do a starter hole. And this was called a bottoming tap. This is really not meant for starting a hole, but if you need threads all the way to the bottom of a blind hole, blind meaning not through, this would be the way to do it in order to get full threads to a certain depth that you couldn't do with the other taps. These are tap handles. We have both. The square drives, and like the top T-handle ones usually come in 3 sizes, and the bottom ones come in all different. I've seen them pretty big. Those are called tap extractors. I've never really had much luck with getting taps out, especially with those things, but I guess it's possible. So that's a die. This is a split die, so you can adjust it, but it's probably best as a rethreading die. And on the outside, I actually see TRW USA, but it says M8 1.25, so that's a metric metric die. And a metric uses the thread pitch is the distance between 2 threads, so it's 1.25 millimeters. That's called a split die. I rarely see those, but you can see the threading action on that. That's a solid die right there, so it's non-adjustable. And that one's 14 millimeter by 2.0. Another metric one, a solid round die. So how you drive a die is you got to put in a round holder, and those little dimples there, which are actually drill points, you run your screw into that to lock it into place. And this is if you look at the end of a shaft, the proper way to, before you put threads on, is you need a chamfer on the end. So these are die handles to run the dies. You can see the thumb screw up there that would lock into the little drill points in the round part of the die itself. And that's somebody there doing hand threading with the die handle. All right. Okay. And I've got a couple more minutes. I could split this up, or I'm going to keep on going. Where's my other stuff? Okay. The drill press project. Let me split that up, and I will do a separate video on that. Thanks.